The Permian Basin produces 6.4 million barrels of oil per day. That makes it America's oil powerhouse, bigger than most OPEC members. But here's what nobody's talking about. That same basin generates 25 million barrels of wastewater every single day. 4 barrels of toxic brine for every barrel of oil. And we're running out of places to put it. In the next 4 minutes, if you bear with me, you'll discover why this water crisis could constrain the most productive oil field in North America, how new regulations just increased operating costs 20 to 30%, and why the industry is scrambling to build a $400 million pipeline just to move wastewater away from the earthquake zone before the ground literally blows apart. I'm Mark Roach, petroleum engineer and deal maker with 30 years in this industry. This is FutureWise Energy, independent analysis. No corporate sponsors, no industry talking points, just what the data actually says about where this crisis is headed. June 1st, 2025. The Texas Railroad Commission implemented the most significant wastewater disposal regulations in the Permian's history. Area of review doubled from a quarter-mile to half-mile radius. Injection pressure caps. Volume limits based on reservoir pressure. Why now? Because Reeves County alone injected 8.6 billion barrels underground since 2010. That's enough to fill the Dallas Cowboys Stadium 462 times. And the geology, well, it's starting to fail. Let's establish the magnitude because most people, including most operators, don't grasp how profound this problem has escalated. In 2017, the Permian produced 6.3 million barrels of produced water per day. That seemed manageable. Fast forward to late 2025, we're at 20 to 25 million barrels per day. Fast forward to late 2025, we're at 20 to 25 million barrels per day. B3 Insights projects 26 million by 2030. That's not a 10 to 20% increase. That's a 300 to 400% increase in 13 years. The water to oil ratio tells the real story. Midland Basin, 3 to 4 barrels of water per barrel of oil. In the Delaware Basin, it's 5 to 6 barrels of water per barrel of oil, with some areas of the Delaware hitting 10 to 12 barrels of water to 1 barrel of oil. These aren't occasionally high water cut wells. I mean, this is the baseline reality of unconventional horizontal drilling in tight formations. Now, here's the chemistry that matters. This isn't slightly salty water. The total dissolved solids are running between 120,000 to 200,000 parts per million. That's 3 to 5 times saltier than seawater. And this cocktail includes benzene, toluene, xylene, polycyclic aromatic hydrocarbons, heavy metals like barium and strontium, hydrogen sulfide, and in some formations, naturally occurring radioactive materials. Toxicology studies show that even at 30 to 50% dilution, Permian-produced water causes significant toxic effects on aquatic organisms. High salinity is the primary driver, but organic contaminants and heavy metals add substantial toxicity. This isn't water you can clean up with a few filters. This is industrial, hazardous waste requiring specialized handling. The traditional answer? Inject it underground through Class II saltwater disposal wells. Well, approximately 75 to 85% of this water still goes into disposal wells. But we've hit physical limits in key areas. The Railroad Commission approved 400 disposal wells in 2021, 480 in 2022, just in the Permian. Demand continues outpacing capacity. Now, here's where the physics stop cooperating with the business model. November 2022, magnitude 5.4 earthquake in northern Culberson Reeves seismic response area. That's Texas' strongest earthquake in 30 years. The Railroad Commission expanded the seismic response area from about 2,400 to 2,600 square miles. The Gardendale area near Midland experienced a magnitude 3.6 and a 3.5 quake late in 2021. Now, the University of Texas research documented 7 separate induced seismicity systems within the Permian Basin, each with unique geologic characteristics. The mechanism is straightforward. Wastewater injection changes subsurface pressures and reactivates pre-existing faults. The complication? Well, scientists are estimating that there's a 12 to 18-month lag time between injection volume increases and the subsequent earthquakes that they create. Current injection practices will manifest as seismicity well into 2026 and beyond. The Railroad Commission's initial response restricted deep disposal near seismic events. Operators shifted approximately 80% of disposal from deep to shallow formations in earthquake-prone zones. That solved the seismicity problem and created an entirely new crisis. October 2024. An abandoned 1961 well near Toyah, Texas, erupted. A 160-foot tall geyser of toxic water mixed with hydrogen sulfide gas gushed uncontrolled for weeks. The rotten egg smell was detectable from 2 miles downwind. The blowout killed all vegetation it touched. Southern Methodist University published a groundbreaking research paper in Geophysical Research Letters in August 2024, establishing, quote, a significant link between wastewater injection and oil well blowouts in the Permian Basin, end quote. The study documented wastewater flowing underground from injection sites before bursting up from old plugged wells 12 miles away. Using satellite imaging, researchers found wastewater injection volumes strongly correlated with a 15.7-inch ground uplift near a blowout site. The research demonstrated that injected water leaked from deep disposal formations into shallower zones, accumulating in aquifers and creating excess pressure that eventually caused well failures. The study warned of a potential for more blowouts in the near future. Here's the mechanism that should concern every operator and landowner. Underground pressure buildup from shallow disposal forces columns of deeper water upward towards the surface, and that water can pass through shallow aquifers, contaminating them. It can force produced water up through aging, deteriorating well casings in thousands of old wells across the basin. And if those casings corrode within an aquifer, the contaminated water flows directly into groundwater sources. The Rustler Aquifer, one of the primary groundwater sources in the region, sits between 800 and 1,000 feet underground. Studies found evidence of wastewater accumulation in formations as shallow as 1,600 to 2,300 feet below the surface, dangerously close to the base of usable groundwater. The SMU research suggested injection fluids were migrating from disposal zones as deep as 3,300 feet to 4,300 feet upward into these shallower formations. Greg Perrin, general manager of the Reeves County Groundwater Conservation District, put it bluntly, quote, As long as we continue injecting, whichever, shallower or deeper, there's so many old oil wells and water wells, and the infrastructure is so corroded that you're going to have leakage. End quote. The June 2025 Railroad Commission guidelines represent a fundamental shift from volume-based to pressure-based governance. 3 primary changes. First, area of review expanded from a quarter mile to a half-mile radius around injection sites. Operators must assess all old or unplugged wells within this zone to ensure produced water can't escape through legacy wellbores. Legacy wellbores being old wellbores. Second, limits on maximum injection pressure at the surface based on geologic properties and mechanical characteristics of confining strata. Third, limits on maximum daily injection volumes based on reservoir pressure at the time of permitting. Now, the Commission's guidelines explicitly acknowledge that conditions in the Permian Basin include large historical and current disposal rates, increased reservoir pressure, and dense historical development with numerous wellbore penetrations. And this creates a risk or an increased risk that fluids may not remain confined. So B3 Insights reported permitting activity shows steady application volumes, but a marked slowdown in approvals as regulators are now applying these new technical review standards. So the expanded area of review around these wells and the stricter wellbore integrity requirements are demanding more documentation and third-party engineering certification, which is lengthening the approval timeframes considerably. Now, in the Delaware Basin specifically, permitting momentum has slowed sharply. Rising shallow zone pressures, seismicity risk, and the expanded 2-mile area of review are constraining new disposal capacity precisely when it's most needed. The economic impact. Well, industry analysts estimate gathering and disposal cost in the Delaware Formation will increase approximately 20 to 30% over the next few years, potentially reaching 75 cents to $1 per barrel. For operators without pipeline access, trucking costs can soar as high as $2.50 a barrel. Railroad Commission Chair Jim Wright acknowledged in late 2025 that while a shift to shallow injection has reduced seismicity concerns, shallow injection alone is not a viable long-term solution. Water recycling has emerged as the most economically viable near-term alternative, and adoption rates are climbing fast. As of 2025, approximately 50 to 60% of produced water in the Permian is being recycled for hydraulic fracturing operations. Projections suggest that this could reach 80% by 2030. ConocoPhillips reported that 52% of water used for fracturing in its Delaware Basin operations and 55% in Midland operations came from recycled produced water in 2021. The economics are compelling. Treatment costs for recycling typically range from 15 to 20 cents per barrel, substantially cheaper than disposal costs at 25 cents to $1 per barrel, or higher with trucking. This cost advantage, combined with disposal capacity constraints, has driven massive investment in recycling infrastructure. Select Water Solutions operates one of the largest commercial water recycling networks in North America with over 3.4 million barrels per day of combined recycling capacity across its Permian facilities. In May 2025, Select achieved a single-day facility record of 500,000 barrels of produced water supplied to a single operator. The company recycled more than 280 million barrels in 2024. Their South Curtis Ranch facility, which has been operational since March 2021 in partnership with Occidental Petroleum, has treated over 50 million barrels. The Lost Tank facility in Lee County, New Mexico, processes up to 180,000 barrels per day with 1.9 million barrels of storage. These operations represent hundreds of millions of dollars in capital investment. Western Midstream announced in mid-2025 this year the sanctioning of the Pathfinder project. It's one of the largest single investments in produced water infrastructure by a midstream company. The $400 to $450 million project includes construction of a 30-inch, 42-mile pipeline with initial capacity of 800,000 barrels per day, expandable to 1.2 million barrels per day. 9 new saltwater disposal facilities in eastern Loving County with combined capacity of 220,000 barrels per day. Multiple produced water gathering facilities. Underpinned by a long-term agreement with Occidental Petroleum, Pathfinder will transport produced water from the Delaware core to underutilized shallow injection zones with lower pore pressure. Service begins first quarter 2027. The strategy is geographic arbitrage, moving water away from high-pressure, high seismicity zones to areas with remaining disposal capacity. It's a $400 million acknowledgement that the geology beneath the most productive acreage can no longer safely handle the injection volumes operators need today. The Bluefield research firm estimates the U.S. midstream water market will total $156 billion from 2025 to 2030, with the Permian Basin driving the majority of investment. But recycling has fundamental limits. Produced water used for completions requires only minimal treatment, removal of suspended solids, bacteria control, scale inhibition. That's straightforward. The extreme salinity and complex chemistry make Permian produced water unsuitable for most beneficial uses without advanced desalination. With TDS concentrations, that's total dissolved solids, of 120,000 to 200,000 parts per million, conventional reverse osmosis systems struggle with high salinity, hydrocarbon contamination, and variable water quality. Several companies are developing breakthrough technologies, though. Aquafortis pioneered a chemical-based desalination process using proprietary absorbents that act as liquid sponges, selectively removing water while rejecting salts and other contaminants. The company claims to achieve greater than 99.9% salt rejection, reducing TDS from 120,000 plus parts per million to under 100 parts per million, at costs lower than transportation and disposal. Potentially the first economically viable desalination solution for Permian produced water. Industry observers predict the first major produced water projects in the Permian will happen within the next year, with substantial scale reaching millions of barrels per day within the next decade. So here's where we stand at the end of 2025. The Texas legislature passed House Bill 49, signed by Governor Abbott, which is effective mid-2025. This landmark legislation dramatically expands liability protections for entities involved in treating and reusing produced water. It shields oil and gas producers, treatment facilities, transportation companies, and landowners from liability in tort for consequences of treatment or use. Entities can still be held liable for gross negligence, intentional wrongful acts, or violations of state or federal law. The Texas Commission on Environmental Quality is working to issue permits allowing 4 companies, including Texas Pacific Land Corporation and NGL Energy Partners, to release treated wastewater from the Permian Basin into the Pecos River watershed. Texas Pacific Water Resources applied to discharge up to 840,000 gallons per day. There's 42 gallons in a barrel. 840,000 gallons per day into a tributary feeding the Pecos River, with approval potentially coming first quarter 2026. NGL Water Solutions, the Permian division, applied for a permit to discharge up to 16.9 million gallons per day near Red Bluff Reservoir. Now, these applications represent a potential paradigm shift in produced water management, though they've raised significant concerns among scientists and environmental advocates about introducing this waste stream into already stressed river systems. Pennsylvania's experience found elevated levels of salt and radioactive chemicals in sediments downstream of produced water discharges. The Pecos River already suffers from salinity problems, and the threatened Pecos pupfish inhabits, well, the very waterways targeted for discharge. The Texas Produced Water Consortium, established by Senate Bill 601 in June 2021 and administered by Texas Tech University, demonstrated that with advanced treatment, 50% recovery rate from produced water to freshwater quality is feasible. Consortium director statements to the Texas legislature in May of 2025 highlighted that recovery of 50% of 25 million barrels of produced water a day has the potential to contribute significantly to the increasing demands of our water, potentially providing enough water to support 5 cities the size of El Paso. Now, looking forward, if current water-to-oil ratios persist, operators could be managing 25 to 30 million barrels per day of produced water daily by 2027. The critical question is whether disposal capacity, recycling infrastructure, and alternative management solutions can scale quickly enough to accommodate these volumes without creating operational bottlenecks or environmental catastrophes. The wastewater crisis in the Permian isn't a future problem. It's a present. It's a constraint today that's reshaping economics and driving consolidation and forcing technological innovation at a pace the industry hasn't seen since horizontal drilling unlocked shale. The convergence of disposal capacity limits, induced seismicity risk, groundwater contamination threats, regulatory tightening, and rising cost has created what some industry leaders are describing as requiring a Manhattan Project for produced water. That's not a hyperbole when you're managing 25 million barrels of oil. That's a lot of water every day. And this is toxic brine, and there's nowhere left to safely put it. So the path forward demands a comprehensive, multi-pronged approach. Continued expansion of recycling infrastructure can address perhaps 50 to 80% of water management needs for operators willing to invest. Advanced desalination technologies nearing commercial viability could unlock beneficial reuse at scale. Regulatory frameworks that balance environmental protection with operational flexibility will be essential. But fundamental physical realities can't be ignored. The Permian's subsurface has finite capacity to safely store injected fluids. Thousands of legacy wells, thousands of old wells create a persistent leakage pathway. The shallow aquifers that communities depend on And these sit in perilously close to pressurized disposal zones. The blowouts and toxic geysers of 2024 and 2025 serve as visceral warnings that current practices are approaching or have exceeded sustainable limits in some of these areas. The Permian's future as America's oil powerhouse depends on solving its water problem. The industry regulators and communities must move from reactive crisis management to proactive, integrated water resource planning. Success will require unprecedented collaboration, massive infrastructure investment, technological innovation, and regulatory evolution. The stakes are enormous, not just for the oil and gas industry, but for the water security and environmental health of West Texas communities that will live with the consequences of today's decisions for generations to come. Stay grounded in the fundamentals, not the narratives. I'm Mark Roach. This is Future Wise Energy.